what is the difference between OR and XOR? Well, when we say OR, what we're really saying is at least one of the conditions has to be true for the statement to be true, or the logic, whatever it is, to be true. So a great example I often think about is food or drinks. You can have two pieces of food. If I say, do you want a burger or a sandwich, you can have one, you can have the other, or you can have both in order to have something to eat. Or another example is this. If I ask you, do you want tea or coffee, the correct answer in order to have something to drink is you can have tea, you can have coffee, you can have both of them. So tea and coffee. A better way of representing OR is to draw what's called a truth table. If we have two events, A and B, for example, tea or coffee, you can have only tea and not coffee. So this would be something like saying A is true, B is false. And because it's an OR statement and only one of them needs to be true, well, the whole statement is going to be true. Similarly, if we were to invert this and not have tea and only have coffee, the statement would still be true because at least one of the two, A or B, is true. In this case, we're taking coffee. If we're taking both of them, so for example, tea and coffee, because at least one of them is still true, right? There's one true minimum here. There's two with two is more than one. That means the whole statement is still going to be true. The last option here is to have neither, and this is really the only way for this to be false, for you not to end up drinking something. So this is what an OR really means in math or computer science or whatever it might be. Now, what about XOR? XOR oftentimes doesn't mean at least one. Usually it means exactly one. So what does exactly one mean? How can you visualize what this sort of option or problem might look like? Well, I like to picture the following. So a great example of XOR, where for OR I think of food and drinks, for XOR I think of traveling somewhere. If you need to get to, for example, the library, you can take the bus, or XOR, you can take a car. Usually XOR is what people use in the English language. Oftentimes when I give a child the option between, let's say, some ice cream or some chocolate, when you're telling them you can have ice cream or chocolate, you don't intend to also give them the option of having both. What you really mean is they can only have either ice cream or they can have chocolate. They cannot have both, right? That is actually a XOR. That is not an OR. That's just something the English language uses because it's really weird to say XOR. Similarly, with this example here, you can take the bus to the library, you can take the car to the library, but it doesn't make sense to take both of them at the same time. You can't take the bus and the car to the library at the same time. So what XOR really differs in between OR is that it's going to be this specific case here when it comes to both things at the same time. Because we're dealing with exactly one, you cannot have the case where both can be true at the same time. Or in a truth table, it would look something like the following. So if we have two events, for example, bus and car, you can take the bus and not the car, and that would mean that yes, you would end up getting to the library. So this would end up actually being true. You can get to the library. The other way around is also going to be true. If you don't want to take the bus, false, but you do want to take the car, true, it is true you're going to get to the library. But instead, if you say you want to take the car and you want to take the bus, well, because that's not possible, it's not going to be true you're going to get to the library, which means it's going to be a false statement, right? This right here is the huge difference between the two logic gates. Similarly, however, with the OR, if you don't take either of these, if both of them are false, your overall statement is still going to be false. But this is generally the massive difference between the two, where one only has a lower boundary, right? You have to meet at least this minimum threshold for the OR to be true. XOR is an exact threshold you have to meet. It has an upper and a lower boundary that you have to stay within. In this case, you can't go over one and you can't go below one. You can't take both cars and you can't take neither cars in order to get to the library. So this is how I usually like to think of these two examples. I like to think of OR being when you can have two things at the same time, and XOR meaning you have to choose one between all of your options. However, remember, XOR oftentimes is really just said in the English language as OR. Like I said with the child example, when you're offering someone the choice between two desserts, you don't really intend for them to have both. You really just want them to choose one of the two, or in this case, XOR, exactly one. So there we go. Hopefully this clears up the difference between these two type of statements in math.